Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in today's video we will see what is recursion in the series of data structures and algorithms. So, recursion is a programming concept where a function calls itself on its own definition. We can say recursive is a function that solves a problem by solving smaller instances of the same problem. Okay, that means it keeps calling iteratively to the same self. Okay, that is the process called recursion. Now, there are two key characteristics of recursive function. One is a base case, second one is the divide and conquer. So what is the base case here means? A recursive function must have a base case that defines the simplest scenario where the function does not make a recursive call. For any recursion function, we should have this base case. We will see that in one example. But for now, just try to understand that recursive function should have this base case. Okay. So in case it helps the function to terminate and prevent the infinite loops, because in the recursive we keep calling the same function within right. So in such cases, if there are any infinite loops and all right, it will terminate when we have this base case. Okay, now second one is the divide and conquer. So usually these recursive functions, right, they typically follow this divide and conquer approach, because the definition itself says that the problem is divided into sub problems, smaller sub problems, and each problem will be solved independently. So the solutions to these sub problems are then combined to solve the original problem. So that's why we can say that one of the key characteristics of recursive function is divide and conquer. So now let's see one example to understand recursive better. Okay. Now let's take this factorial of 5. So finding the factorial is the best example for recursive function. Why recursive is, if you see, if we want to get the factorial of 5, we have to say 5 into 4 into 3 into 2 into 1. So whatever number we are trying to get the factorial, we have to multiply with all the previous integers, positive integers, correct? And then finally that total multiplication of that entire series is considered as the result of this factorial of n. Now if you take it in a mathematical way, right, what is happening? Let's say in this case n equal to 5, correct? Because we are trying to find the factorial of 5. Now when you say the solution this way, try to understand like how to write it in a mathematical formula way. Okay, now if you take the first step is n into, because now first we are doing what is 5 into 4 into 3 into 2 into 1. So then what it will become is 5 into, let's write first this way, 5 into 4 factorial, correct? Next what happens from this step, 5 into this 4 into 3 into 2 into 1 will become the 4 factorial, correct? And then next what will happen, 5 into 4 into 3 factorial, correct? And then 5 into 4 into 3 into 2 factorial, and then 2 into 1 factorial, something like that. So this is how this is being built, correct? Now let's try to generalize that not only for 5, for any number being sent as n to the input as to the function as input. Now consider n as 5. Now how to write a programmatic way, I mean mathematical way, is what exactly we are trying, n into, if you take 5 and 4, right, we are subtracting 1 there. So it will become n minus 1. So n into n minus 1. And then what we are doing, n minus 2. And then n minus 3 and so on, correct? This is how here we are doing it. And then we are multiplying it all the that results, correct, multiplying each every digit, like making it -1 and then multiplying it to get the result. So now if you see here, there is like we can substitute this 1 2 3 with usually how we do in the for loop, correct. So now let's write a simple Python code to see how we can recursively call the same function to achieve this kind of mathematical way of calculation. Okay, now let's create one function and we'll pass an input to this. Okay, n as the input means whatever number we are trying to get the factorial, that number we are passing as input to this function. Okay, next, first if you remember the finding the factorials, right, we always know that for 0 factorial and 1 factorial equal to 1. So here we will add that case here. Why we have to add is, I will explain you in a minute. I'll just write down this code, then I will explain. Okay. So if you see here, what we are doing is n into n minus 1. Similar way here, instead of n minus 1, we are calling the function recursively. The same function will be called multiple times. So now let's see. If you see, this kind of by default case is called as the base case. And here we are dividing this into multiple smaller problems, right? So this is the second characteristic that we have discussed about. Okay, we are dividing into multiple smaller problems and then finally we are returning it, means we are finally combining to the original solution, combining as original solution. Now we are sending 5, let's say. First what will become is n equal to 0 or n equal to 1? No. So it will come to the else loop. Now here 5 into factorial of 4. This is the meaning of it, right? N minus 1 is 5 minus 1 equal to 4. Now here again we are calling the same function. So again it will go, now n equal to 4, right? So 4 into factorial of 3. It will become like this. Then in the next iteration 3 into 2 factorial. Then in the next iteration it will become 1 factorial. Now if you see n equal to 1, so it will return 1. Otherwise what will happen is, if you don't have this case, again it will come here, it will become 1 minus 1 0. Then in the next iteration again it will become 0 and it will just go on, it will go into a infinite loop. So for that reason we have a base case here. Okay, now this is the result, and finally once it is not here and then it will return here, right, there is nothing, then it will become 0 and it will return 1, and finally the entire result will be sent to the main function. This is how we can calculate the factorial of n, and by calling this recursive function. Okay, now is it clear? Now as we are talking about this one, right, when we write some code and like this multiple times, when you are calling the function within, then we all get a question like how the memory will be managed, correct? So let's see that with an example of this factorial. So if you see here, we are trying to get the 5 factorial. So what will happen is, when a recursive call is made, it adds a new stack frame to the call stack. This is the new stack frame. Okay, in the memory a new stack frame will be created. So this call stack is the region of memory used to manage the function calls, and it returns in the program. So when a function is called, the stack frame is created to store the local variables. Local variables here means if we are passing the value to the n, right, that one, and the parameter and even the return addresses, everything it will be created. And when finally we are returning this function, then this stock frame will be removed automatically. But when we are running the recursive program, this stack frame will be active. So when you are sending this 100 as input to this recursion function, right, recursive function, then 100 stack frames will be created in this fashion. Clear? Now first it will, for when we pass n equal to 5, right, the local value, like the local variable n will become 5 for the first iteration, and it will create this stack frame with the 5 factorial. And then in the second iteration again, I mean, when it reach to the first call, right, if it goes to the else condition in our code, if you remember, it will go to the n into factorial of n minus 1, which is in the else condition, correct? Just compare again. So this one, whatever is highlighted here, at first time it will come as n, and 5 into n is 5, right, 5 into factorial of n minus 1, which is 4. Okay, it comes here. Then again we are making a recursive function here, a recursive call here for the 4, right? So that's why it will create another stack frame with 4 into n minus 1, which is n minus 1 means 4 minus 1 equal to 3. Then again in the 3 we are making, it's not direct n minus 1, right, it's the factorial of n minus 1. If you see here, this is the function call we are making. So again it will create one stack frame and it will create 3 into factorial of 2. Then again it will create another stack frame, then finally it will reach 1. For the 1, what code we have? Return 1. So that 1 will be returned here. So for this, as a result, it returns 1, and 2 into 1 equal to 2. That 2 value will be returned here. So 3 into 2 is 6. That 6 value will be returned here. Okay. Then 6 4s are 24. That 24 value will be returned here, and 5 into 24, which is 120, will be returned to the final here, this stack frame. Then finally that 120 value will be returned to the main function. So this is how in the memory the stack frame will be created, and once this final result is sent back to the main function, all these stack frames will be removed from the memory. Okay, so the memory will be free after the recursive function, but please remember that when you are working on the production code, remember to wisely choose when to use recursion, when to use iteration, okay, because of this memory consumption. Next is, as I said, we understood how the memory will be stored for recursive memory, when it is the function call is happening for the local calls, right? Local variable calls and return addresses. And then we will see what is this recursion and iteration. So why we are comparing even this is, let's say here we have this function inside this if loop. So here we are again calling, means for each n iteration it will continue, right, because we are iteratively calling this factorial function. But I mean, we might get a question like, why can't we use iteration? Is multiple if else conditions you might have to write for that. That's why we have this recursion function. But recursive, again, internally it is doing the iteration, right? Then what is the difference? The first one is here when the base case is reached, it will be terminated in the recursion. But in the iteration we will have to give the condition, right? The condition, when that condition, usually we give, right, I equal to 1, I is greater than n, something like that. So when it reaches that condition, then it terminates. And also recursive, we have to remember, like when recursive call is happening, we need extra space for creating the stack frame that we have seen, right, with the diagram explanation. But in iteration it does not require any extra space. And in here, sometimes when you are passing some very high value as input, there may be chances of running out of memory and result in stack overflow because of the memory consumption. As I said, if we are passing a big number as input to this recursion, it is going to create so many stack frames, and it will consume, and we might run into out of memory exceptions as well. But iteration, it will not need any extra space, right? So it is better but we just have to make sure that in the conditions it should not go into a infinite loop, even though it's not consuming any extra memory, but it's always better to see that it is not going into the infinite loop. Okay, and as I said, recursion and iteration both are very good solutions for certain problems. So it's we have to wisely choose when to use what. Okay, that is the main differences. This is about the recursion, friends. I hope this is useful to you. Thank you for watching my video. Please subscribe to my channel for more interesting learnings. Thank you.